Hello and welcome to QED's Data 5 from part S27. So we have the data in stata and we need to label the variables. So we can do that here. So we can label the binary variables. So first we have to define a label. And we can call it anything you want, but I'm going to call it yes, no label. And 0 is going to mean no. And 1 is going to mean yes. And so that defines the label. Then you just apply it to the variables. So now it gets a bit tricky because we need to know exactly which variables we want to label. So for ease of reference, I might go back to here and just go through them. So this is a yes, no, this is a yes, no, this is a yes, no. So I'm going to put it so we can see, oops, all of these. And this might be one where I have to pause it and just go through and do it and show you what happens in a minute. But what I'll be doing is going through and saying, okay, I want fisheries one, fresh cis is another, marine cis, pretty DOM water, domestic water supply, irrig water, and so on. So I'm just going across and typing in all the names of the variables which are clearly 0, 1s, 1. So it's actually, in this spreadsheet it's going to be almost most of them, I think. So I'll carry on doing that and then unpause them. So there we go, I've typed in all across to here. I'm going to leave out multi-1 and multi-2 because it's not completely clear they're yes, no's. I think they're something slightly more complex than that. And we probably won't use those in the analysis anyway. So that's the list of names. Then we have to put yn label on the end. So it's going to apply this label to all of those. If we get an error, it's probably because I misspelt one of these, but let's just see how that works. Let's do all those, I think. It seems really happy. Good. And if we go to the data browser, see what the transformation has made. That thing we had 0s and 1s everywhere. Now we've got yeses and nos everywhere, except for the last two which we didn't label. So that makes it slightly more readable, the yeses and nos. This we can leave as a string variable for now. Okay, so first question then, what is labelled is there any difference in the proportion of these areas who've got potential to avoid emissions between those that do and do not provide irrigation? So can you apply a test to assess this? So we're looking at emissions and those that do not provide irrigation. Oh yes, that's that. So we browse the data. Where's the data gone? So it's avoid. I think I omit this one here. So it's yeses and nos here. Is there any connection between the yeses and nos here and the ones that do or don't have the potential to avoid emission? But those that do or don't provide irrigation. So irrigation is over here. So we're looking at the connection between this column here and the emit void. So looking at percentage of yes and no's here, does that percentage of yes and no's change according to the irrigation water? So null hypothesis could be that the proportion of KBAs who have got the potential to avoid emissions is the same among those that do provide irrigation as among that don't provide irrigation. And the alternative would be that the proportion of the KBAs that have got the potential to avoid emissions is the same in those, is not the same in those that do and don't provide irrigation. And the test obviously is a test of proportions. So if we head off to do for indicator, we can do the what was it called? It's emit void. It's quite. It is good the way that it reminds you of these. And what's the one called? irrigation. Oh, good grief, look at that, very good. So that's the test we want to do. So put in a suitable comments and carry out that test. Oh, there's an error in the data for emit void. That's not what I found before. Let's go and check that. Find the data. So emissions voids. 2 ways of doing it. You can just check down here and see what data there is. And it seems that's all yeses or nos. Aha. There's something strange going on at the end here. Got some missing values and you've got a 92. So what I suspect has happened is that there's a problem back in the spreadsheet of data when we're concentrating on the top with all the mess at the top, and there were some unusual things going on at the end. So if we go back to the spreadsheet of data here, and oops, plants right down to the end. Yeah, we'll see there's a total, so this is just a mess. So we definitely don't want that in there. So what we do is just get that and delete it. Delete those rows. That's better. So that's now the end of the actual data is there. Check there's nothing unusual happening at this end of the data. No, nothing there. Great. So now we've got nothing but data, what we expect data. We save it. And before we finish the video, we'll just point out that even though it looks like a pain because we have to go back to the start, the joy of do is that we can just run the whole thing again, including importing it, including all that up to here, and see if this time it's any happier. Yeah, this time it's done it. It's done. So it's imported everything again, and this time it's run the test. So it's looking at the difference in proportions, and clearly it's a clear reject. So the proportions clearly are not equal. So interesting. That's quite strong. So there seems to be very strong evidence here that the proportion of sites where there is potential to avoid emissions in future is different between sites that are currently providing irrigation water and not providing irrigation water. And it seems that it's the ones that are providing irrigation water have got the highest proportion. Yeah. So it seems that there's a higher proportion, almost 50% of the sites that are providing irrigation have also got the potential to reduce emissions, compared to only 8% of the sites that are not producing irrigation. So clearly that's an important finding in terms of its real meaning, as well as the fact it's significant and it occurs outside the sample. Okay, so that's the first significant, in both senses of the word, finding from the data. Okay, so question 12, yes there is, and you can apply a test which we've done. Okay, now we're going to make sure we save that. Save the set as a new data, which I haven't done so far. So we're going to save the set as a new DTA file. So I'll add something to the thing here to do that. So I'll just add a line in like this. I've taken the line as part of the name of the Excel file, and I've called it number 1, because that's the data on sheet 1. So I'm just going to save that. And then we can go ahead now, and because that's saved as a DTA file, so anytime you want, you can just reopen that as a data file straight into Stata without going from Excel. So that's saved as DTA. And then I'm going to clear the memory and do this similar steps again to import results from here. So we have to go into Excel, do a bit of tidying up to get the variable names ready, and then we can import it. Okay, so I'll come to that in the next video.